In the last video, I mentioned that pilot skill rolls to prevent a mech from falling can be required in the movement phase, weapon attack phase, or the physical attack phase. However, I forgot to mention that pilot skill rolls to prevent falling can also be required in the heat phase as well. Pilot skill rolls and falling come with a significant amount of detail. Accordingly, to prevent rules overload, I'm dividing up how they work into multiple videos. This video explains how zero level falls work in water. The main water depths we need to worry about in BattleTech in regards to battle mechs are depth 1, depth 2, and depth 3, because on the piloting skill roll table, we see that if a mech enters a depth 1 water hex, it must make a piloting skill roll with a modifier of -1. If it enters a depth 2 water hex, the piloting skill roll modifier is 0. And if the mech enters a depth 3 water hex or deeper, the piloting skill roll modifier is +1. So, suppose our Thunderbolt walks into this depth 1 water hex. Now, since this mech's piloting skill is 5, we add a -1 modifier to the 5, yielding a target number of 4 this mech must meet or beat to stay standing. Let's see if the mech stands. Yes! A 9 is equal to or greater than a 4, so the mech stays standing. But let's see what happens if the mech walks into the depth 2. Now we add a +0 to its piloting skill mod of 5. The target number is thus a 5. 4. No, the mech fell in the water. Now, we check the facing after a fall table to see what the facing is of the mech that fell. 5. That's 2 hex sides left. 1, 2. And it fell on its left side. So it fell on its left side and, of course, rolled over to be face down. Before we apply damage to the mech, we need to see if the mech pilot received a hit. We need to make the seatbelt check. This seatbelt check, or second piloting skill roll, includes all modifiers applied to the first piloting skill roll that caused the fall, with an additional +1 for every level above 1 fallen. Accordingly, the target number is still just 5. Six. So the pilot remembered to wear a seatbelt, and he does not receive a hit, so we make no tick right there. Now we calculate damage. Here lies the damage formula for falling in water from a standing position. It is tonnage divided by 10, round up, times the number of levels fallen +1, and we divide all of that by 2, rounding the final number down. Our Thunderbolt weighs 65 tons, divided by 10, times the number of levels fallen. We treat this as a 0 level fall, so 0 plus 1 divided by 2. Let's start with 65 divided by 10. That's 10, 20, 30, 40, 50, 60, 65. That's 6.5, which we round up to 7. 65 divided by 10 yields 7. Times 1, because 1 plus 0 is 1, divided by 2. Well, that's just 7 divided by 2, which is equal to 3.5, which we round down to 3. and we divide that 3 up into 5 or less damage value groupings, well, we don't even have enough for a single 5 damage value grouping. So the total damage going to the Thunderbolt will be 1 damage value grouping of 3. Now we roll for location on the left side column because the Thunderbolts landed on its left side. Eight. That's the center torso. The center torso takes 3 damage. Now, because this location took damage while the mech resided underwater, we must check for a hull breach in this location. That means on a roll of 10 or higher, the hull is breached and water floods into the center torso. Seven. No. The hull is not breached. So everything's okay. Everything's still working just fine. However, I want to demonstrate what would happen if the hull is breached. So let's just fudge that roll up a bit. In this case, the center torso floods with water, and everything in the center torso ceases to function. The ammo stops working. It acts as if the ammo received a critical hit, but it doesn't. The ammo doesn't actually get a critical hit because the ammo does not explode. So the ammo's not working anymore. The mech also receives as many critical hits to its engine as the engine has critical hit slots, or it acts as if it did. So there's 1, 2, 3, 4, 5, 6 fusion engine slots here. So those are all not working anymore, which means we have 1, 2, 3, at least 3 engine hits. And the gyro's not working anymore. That's a non-functional gyro, so the gyro's done. This mech is basically done. The mech center torso does not function anymore. This is a done mech. It's great for salvage though. Now let's say that let's say the leg took some damage. Say the leg took 3 damage. In this case, we would roll for a hull breach as normal. And the leg's fine. But supposing the leg was not fine, then everything in this leg, everything here, all these parts would cease to function. To just act as if they don't work anymore. And the leg freezes up. Same thing for an arm, analogously. Interestingly enough, if a side torso took damage underwater, and if that side torso failed the roll, let's see. 8. Yeah, totally failed the roll. Then not only does the side torso breach and fill with water, but also the corresponding arm, in this case the left arm, would fill with water and become non-functional as well. The best part about all this is that leaving the water does not restore function to anything. So if this mech were to leave, the left leg wouldn't drain and start working again. It's just done for the rest of the game. And naturally, if the head took a hit, we would have to roll for a hull breach. Which, yeah, we'll say that happened. In which case, if the hull is breached, the cockpit fills with water and the mech pilot dies. Now, bear in mind, you only make these rolls if the mech receives damage when it's underwater. If the mech is already damaged and it walks into water, so let's say the mech's out of water, and the mech has this damage to it. Once the mech walks in, it doesn't need to check for a hull breach. Everything's fine. Now, of course, if, say, the entire left arm had no armor in it, but still had structure, and if this mech went to a depth 2 water so that its left arm is submerged in water, in this case, the left arm becomes non-functional because there's no armor keeping the water out. There's a hull. It's an automatic hull breach, and everything in the left arm ceases to function. I end by clarifying this distinction between a mech acting as if it took a critical hit and a mech actually taking a critical hit. When a mech actually takes a critical hit, that means that some part of the mech's internal structure, which the external armor protects, some part of that internal structure took damage from incoming fire or falling damage. Some physical thing changed the physical structure of a component of internal structure. Example, a shoulder actuator in the mech. It has a certain form. If, say, an autocannon shell breaks through the armor and hits the internal structure that is the shoulder actuator's form will change from the incoming force, and it won't function anymore. It will have taken a critical hit. This is different from the right arm flooding with water, because the water stops the shoulder actuator from functioning due to water damage, but the actual form of the shoulder actuator hasn't changed, so it hasn't actually received a critical hit. Accordingly, the shoulder actuator can take a critical hit in the future after suffering water damage, but at both times the shoulder actuator doesn't work. This is important for ammo, because ammo that's been flooded acts as if it takes a critical hit because the ammo ceases to function. However, the ammo did not take a critical hit, so the ammo can still take a critical hit later. And if the ammo takes a critical hit later, the ammo will explode. But ammo that gets damaged due to water does not explode. And each internal component, be it a lower arm actuator, a foot actuator, a shoulder actuator, whatever, can only take a critical hit once. This will make more sense when I cover critical hits in a future video.